Critical points help us determine when the slope of our graph is 0 or undefined. Today I'm going to show you how to calculate the critical points of a function. Given f of x equals 5x squared plus 10x minus 5, we can see on the graph that there is a point that looks like the slope briefly becomes 0. To help us find this value, the first step would be to take the derivative. So doing so gives us f prime of x equals 10x plus 10. The critical point is defined as the number c such that the derivative of a function at that point is 0 or does not exist. Or more concisely, you can write it as f prime of c equals 0 or does not exist. Visually, you can think of this as when the slope of a graph is 0. Next, we'll set our equation to 0, which leaves us with 10x plus 10 equals 0, which then leads to x equals negative 1. To verify this, we just have to plug it back into our equation, giving us f prime of negative 1 equals 10 times negative 1 plus 10, which equals 0. Therefore, this validates that our critical point is in fact negative 1. Next up, we have a slightly more difficult example. So f of x is cos theta plus cos squared theta, and looking at this graph, it looks like there might be a few places the derivative could be 0, and so there may be more than one critical point found. So, following the same logic as before, we'll take the derivative, which leads to f prime of x equals negative sine theta minus 2 cos theta sine theta. We can factor this further, giving us negative sine theta times 1 plus 2 times cos theta. Now we can set each to 0 to help us find the solution. Doing so actually gives us two sets of solutions. So looking at the graph of sine x and cos x over here, we see that sine is 0 at every n pi. And so our critical value is n pi for sine theta for our first part of the equation. For the second term, we can also factor further, giving us cos theta equals negative 1/2. This is true for when theta equals 4 pi over 3 or 2 pi over 3 and does repeat every cycle. So this would be 4 pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n. Therefore, the critical values at f prime c equals 0, where c equals n pi for the sine term, and then 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n for the cos term. So our final example is going to be f of x equals ln to the 4x plus e to the 4x. So as before, we'll take the derivative, which is 1 over 4x times 4 plus 4e to the 4x, which then equals to 1 over x plus 4e to the 4x. So if you actually attempted to find the critical points, you wouldn't be able to do so, and this is because there is no point on this function where the derivative is 0. You might also wonder before, I said that it's also for when they don't exist, and the derivative of 1 over x, 1 over x has no solution for x equals 0. But this is because that x equals 0 isn't in the original domain of the function. It's not defined for that function. So it's critical to realize it is the derivative which isn't defined, not a point on the original curve which isn't defined. So remember, critical points happen where the derivative is 0 or undefined, and they're key to understanding a function shape. Like, comment, and subscribe if this helped.